And the supply of the factors to the firms can also adjust, right? So not just the firm adjusts its supply, but also the people who supply factors to the firm can make changes to their durable inputs. So again, all of these are just heuristics. They're all just things that are often show up in the textbooks, and there's lots of counterexamples. So, for example, I don't know if anyone follows Groupon, but almost immediately after Groupon came into the market, it had like 7,000 competitors, right? And so that shows that entry, at least in this day and age, is really not all that durable, right? On the other hand, the medical industry has taken a huge amount of time to respond to the enormous increase in demand for medicine by actually having more doctors, and has hardly brought in any technology in response to this either, because there are things that slow down that we talked about earlier in the class. So legal and institutional context are critical to what can be adjusted over what runs. And furthermore, just saying the short run, the medium run, and the long run is a little bit silly, because in the end we're talking about how many years it actually takes, not like which run it is. But still, they're somewhat useful concepts. So, Sean Pierce? Oh, Steve, you're Sean. I didn't realize that. So, can you tell me how the long run versus the short run marginal cost curves look like, or you want to come draw them, or?
Marginal cost curve, I guess. I don't remember exactly what they look like.
Anyone else want to give it a try? Yeah, Karen.
In the long run, supply is more elastic, so the curve is less steep than the short run.
Yeah, and is there one other connection between them? What point do they intersect one another?
I think they intersect at the price. I'm not wrong.
Yeah, at the long run equilibrium price. That's right. So if this is the long run equilibrium price, P, then this might be the short run marginal cost. And then the long run marginal cost will go through the price as well, because it has to be consistent with the long run equilibrium, but it will be more elastic. On the other hand,
I have a question on that. Why are you using the long run equilibrium price for the short run marginal cost? Why? How can you do that?
because every time we draw one of these curves, we sort of think about like the changes coming from the long run equilibrium, right? Because we're thinking about, okay, there's going to be some change in the market conditions to some other situation. We want to know how the firm will react, starting at the long run equilibrium, right? And so that's why they start at that same point. Okay, Edward, what? Edward, you want to come draw or tell me what the average costs look like between the long run and the short run?
It would just be like, maybe more flat than just the marginal cost curve, wouldn't it?
No, so it actually has kind of an interesting relationship. So the relationship that it has is that, so imagine this is the long run cost curve, right? The medium run cost curves are going to, remember that if those are at the long run equilibrium, they have to have the same marginal cost. That means that they have to be tangent to the average cost at the point where that would be the long run equilibrium, right? So the medium run curves will look like this. So they're going to be more sharp around that point because that represents the fact that their marginal cost is steeper, because marginal cost is roughly the slope of these guys. And then they have to be tangent at the points at which you would be at long run equilibrium producing at that level. Right?
If you were to drive like long run from medium run, you would just like aggregate all the medium run once at the point where they should.
Exactly. So that, what you just described, is called the envelope theorem. So the envelope theorem states that the long run curve is the envelope of the short run curves. It adds up all of their points of tangency. Yeah?
So why is the tangency between the leftmost short run and the long run average cost curves? Why is that not the minimum, the global minimum of the short run average?
Well, so it would be if there were arbitrary numbers of different possible levels of the curve. So, you know, it would be that if, yeah, I mean, in some ways I should draw it that way because I'm sort of drawing the curve like that. If there were discrete levels, then it would be sort of bumpy, and then it wouldn't have to do that, so yeah. But then we can look at the short run. What will the short run be like? Well, that will also be like this, right? So those will be the things that make up the medium run. And then if we go to even shorter run, where less things can be adjusted, those will be, you know, so they're all envelopes of one another. So that's the envelope theorem. It says that if there's one thing that you can adjust and one thing you can't adjust, the derivative, if you can adjust everything, is equal to the derivative when you can only adjust one thing at the point where that other thing was optimal. Okay. So, again, we can interpret these as response to different duration shifts, right? But if we start to take seriously this notion of time and the length of time over which a shift is likely to occur, we have to ask a bunch of questions because, you know, the situation I described is if the shift is going to last for this amount of time, you know, what will you do? But of course, lots of shifts aren't exactly like that, right? It's not like they just last for a certain amount of time and you know with, you know, absolute certainty that they're going to last for that amount of time and so forth, right? There's a lot of uncertainty. You might, you know, suddenly find out that something's going to last, or you might anticipate that the thing's going to happen. And you know, there's all sorts of complicated things that can happen in dynamics. So, for example, one example is what's the relationship between the length of durability, like how durable something is, or over what time, how much time you need in order to change it, how long it takes for it to depreciate, and whether we consider something to be a short run or a long run. What are short-term reactions to sudden shifts that are very long-term like? So, for example, imagine that the computer is invented. Suddenly, we know where there's going to be a totally different world. What happens in the very short term? Is that the short-term curve or the long-term curve, or what? Right? What is the long-term effect of there being repeated short-term shifts? So imagine that every year things are, you know, there's a lot of demand for oil in the summer and not very much demand during the winter, and then there's demand for coal during the winter and so forth, right? But if there's lots of short-term shifts, you know, what effect does that have? What if it's unclear how long the shift's going to last? What is the actual path in which the firm's adjustment takes? So not just what is its average production over some period and so forth. So these are the questions that are usually addressed by economists in what are called dynamic models. And these models explicitly have different time periods rather than just having, you know, like we do, there's one curve, there's like something corresponding to all the different time periods. But these models get extremely complicated and confusing. And so what we're going to try to do again instead is just to think about things in terms of the types of curves we've been talking about. but try to reflect in a more informal way upon the role that time plays, and this will hopefully help us to think about some of these dynamic issues without having to get into all the complexities involved. And the thing to keep in mind is that anytime we use a static model, by static model I mean all the models we will use in this class, where there's just some curve, what we're really trying to represent is what happens on average over some period of time in the real world, right? We're not just talking about some abstract thing where things happen all at 1 second, as the model sort of pretends like it is. Instead, we're trying to describe the average behavior over some period of time. And so to use those types of models intelligently, we have to have informally in the back of our minds what the actual dynamics of the world are and how those relate to the model. Okay, so let me go through some different types of demand shifts. So one is what you could call a one-time permanent shift. So for example, when the iPad came out, that probably forever reduced the demand for paper, right? Yeah.
But that's not like that like takes time to like for people to like start using the iPad. It's not like a
Sure. No, that's right. There's going to be an adjustment, but sort of the firms can now predict that forever the demand for paper will have dropped, right? Another one is a one-time temporary shift. So an example of that was that there was a big demand for cupcakes. I don't think anyone thought that fad was going to last very long, but there was a period of 2 or 3 years where like cupcake shops were like, I mean, it might even be going on still. But I don't think anyone thinks that's going to last for very long, right? That's just sort of like a fad that came and will go, right? Another one is what's called a secular trend, where we sort of know that something is gradually increasing. So an example of that is the demand for medical care in the United States and for education. So we know that demand for medical care is gradually rising over time. It's very predictable, and there's a trend. Another form is a predictable cycle. So for example, seasonal demand for vacations. The demand for vacation goes up during the summer, and demand for electricity goes up during the summer, and they go down in the winter. And one important impact of having cycles like that is that if you have durable inputs, it makes production much less efficient. Why is that? Because you have to have these giant power plants so that they can supply the peak of the demand, and then they don't have anything to do with the power plant when the demand is lower, right? So when there are durable factors which can't easily be adjusted over the length of the cycle, production is much less efficient when there are cycles than when there aren't. In an unpredictable cycle is another way something can adjust. So men's underwear apparently is very, very cyclical. So during recessions, men wear their old crappy underwear and never buy new underwear. So this is an unpredictable cycle. We know it's going to go up, we know it's going to go down, but we sort of don't know when, because we don't know when the economy is going to go up and down. Another way is just things can kind of move all over the place in no particular pattern, but very often. So fashion is an example of that. The demand for gold is sort of like if people get scared, even if the economy's not doing bad, it goes up and down. Diamonds follow a similar pattern. Okay. So in the previous lecture, we treated factors as exogenously fixed or variable, or quasi-fixed, right? But what I think you can see from what we've been talking about is whether something is fixed or variable all depends on the duration of the production, right? So if a factor is durable over a very short period only, and you're talking about a long run, it's going to be a variable factor. If it's durable over a long period, and you're talking about a short run, it's going to be fixed. To illustrate that, let's consider some examples. So imagine that we're talking about a 5-year run, and the input to our production process is an iPad. Shin,
Yes.
what do you think that would be variable or fixed, or where along the spectrum do you think?